plus 1. We're going to set it to 4.
Okay.
It's equal to cow plus 1. Now we're going to increment it, but it's not, that doesn't matter to us. The actual loop itself is not going to execute because it's going to be set to 5, and we're not going to execute this loop. All right? And so this is 1, 2, 3.
Okay.
The other one's going to be the same thing. So if you execute the other one 3 times, this is executed 3 times, but then it's also executed 3 more times because of the outer loop, we're going to get 9.
Okay.
Andrew, do you have a
3
question?
times 3.
It's because they're not actually related. The other ones were like n times, and then it was the same
Yeah.
inside, right? And these are actually 2 different.
Well, it's not so much that they're different, it's just that the fact is that the executional loop is not going to take n times, okay? It's going to be some constant number, which in this case happens to be 3.
Yeah, this one we gotta find a number of things. We've gotta, where the other one we ran from 0
it's a
to that
constant.
max size.
Exactly, right, exactly.
N values. This one just says there's always 3, no matter what number we're going with.
No matter which number we choose, it's always going to do it. Always going to do it 3 times.
And it doesn't matter what constant it is, it's going to be big O of 1.
Yeah, it's going to be big O of 1. If it's some number of executions, no matter what, it's always going to be big O of 1.
I got it.
I got it. There was an extra.
Okay. Okay, work on the first one, and then we'll talk about it. Okay. So again, work in pairs, or however you want to work it. Don't work on yours by yourself.
All right, you and me.
I don't know the other one. So this will be.
It's not going to go back to
No, it's not constant.
Correct.
Just count the number of operators.
Okay, so we got a loop. Random, less.
We get that first one.
If 10. It's not actually. That's the when you decide these are all linear,
Well, except for.
well, yeah, because they define it, right?
Yeah.
You're saying 4
The other ones were of length.
unknown. Yeah.
So we have still conscious, so actual.
So I mean, whatever number it is, it'll either do this or this. Just one.
Now this is what we're talking about.
Yeah.
We don't know.
So that's n times however many stages.
I see what you're saying. I see what you're saying.
Yeah, but nonetheless. Yeah, that's what we've got.
Now we got they're actually the same end. That thing is that would be an n times n situation, and then part of the time.
Well, they trigger one or the other triggers all of them. So we have
Set up. Now we got 4.
Okay, let's go over the first one and maybe the second one. So if we're looking at this one right here, Tony, is there anything that we need to be? I mean, is there anything in here that's going to be in terms of the size of our input?
You're just incrementing by 1.
Exactly, so each one of these we're just gonna count as a value, right? And I don't know, I forget how many statements there are, whatever. 12, okay, so we're gonna run this thing and there's gonna be 12 executed statements. What is that gonna be in terms of n? It's gonna be constant, right? So this is that's gonna be big O of 1. Go ahead for the next one, man. Did you guys get that one? Flip. Let's stop these arguments. So, May, what did you guys come up with a determination on this one? Big O of 1, okay? Is there, so we're looking at this again in terms of the size of our input. Is it gonna matter what the size of our input is? There really is no input that we're even worried about, right? And so we're look at this, the way we can count this, we can say, okay, this is always gonna execute, right? We're always gonna do this evaluation. And we're either gonna do this, or we're gonna do this. So how many steps is that? How many states? It's always going to be 2, right? So it's never going to change depending upon the input, okay? How many of you are still working on hello? A few of you? Okay, I'll get back to you in a second, okay? Go ahead and work on hello and then the next couple of you.
I is less than 7.
Because while loop is in it, just like, no. No, it'd be, when you run 4 times, it'd be big O.
Oh my God.
Assuming that
Still gonna be, yeah.
That scares me. But it's still a bounce over. Just because C is incrementing, right, doesn't matter.
N minus
I is 4. 4 is less than
minus the number of 4 is less than n time. This one is going to get smaller.
Much smaller, well, yeah.
Right? So it's really just a quadratic. This one is only 1 less than that. So it's still n.
Okay, let's go over the end close.
3 in a row.
So Jake, did you guys get this one done?
Yeah.
Okay, so what did you guys come up with?
As far as the big O, or?
Yeah, what's the big O on this one?
We said it was N.
Was that? Why did you say that?
Because we're running through that loop N times,
Okay.
and all the operations all the operations inside are going to happen N times as well.
Okay. What were you going to say, Kevin?
Because we have to say that n is greater than or equal to 4.
Okay.
That changes what will happen to the logic because it only matters if n is 4 and it's greater than 4, it's not so
Okay. Assume that n is greater than or equal to.
N times.
So, but in terms of, okay, but again, we're assuming though that n is going to be what? Is it going to be 4?
So we're assuming it's going to be huge.
We're assuming it's going to be huge. Okay? We're looking at a billion n, okay? And so in that case, it's because technically the loop doesn't start until what? I equals 4, right? Right? So actually we could subtract n minus 4 would actually be the number of times we're going to execute this thing. But if it's a billion minus 4, do we care? And so, yes, we can count up all these statements. We can count up the fact that there's 2 in here. And we can execute this n minus 4 times 2 or whatever. The point is that as a growth rate, it's still going to be bound by n, okay? That's going to be the upper bound of this one. So it's going to be big O then, okay?
I don't,
We got away with it this time, good luck erasing it.
What's up?
Seems to me like it'd be just incrementing.
Well, it does, right?
So isn't that by one? So it's gonna run this one, and then this one, and then this one?
What do you mean? This part? Or are you just talking about this?
Yeah.
So this right here, so let's say that we have, okay, so I is equal to 4 initially, right? N is equal to 10,000.
It's this thing.
How many times is this, how many times is this statement going to be executed?
And 10,000 minus 4.
Exactly, right? So in terms, and then, so we're going to do this 2 times, right? So we can say that roughly we're going to have what? We're going to have 10,000 minus 4 times 2, right? But again, this is our value of n, right? So it would be 2n minus 8. In terms of n, it's going to still be big O of n, right?
Yeah. Okay.
Okay? All right. How many are still working on the next one? We kind of have pushed. Harmonic? Okay, big O of n. Does anybody disagree with that, big O of n? The only difference on these loops that you'll notice is this starts at 1 and it goes to less than or equal to n. How many times is that going to execute? N, right? Okay. And then of course you got this. This is going to do n plus 1. This is going to do n. This is going to do once, and this is going to do what? N times, right? Okay. So if you're just still counting, but the idea is it's still going to be in the big O of n. And what about divisor pattern? Alicia, were you guys able to get to that one?
Oh, big O to the n squared.
Big O of n squared. So we've got this is going to go n times. This is going to go n times, right? And then inside of here, does it matter? Really?
One or the other.
See, it's always going to execute this, and it's either going to do this or this, so it's going to do 2 times, right? So it'll be 2 times n squared, right, for this whole thing. How many times is this going to be executed? N times, right? All right, so, you know, if we're looking at big O again, it's still going to be just n squared.
Yeah, I can't wait.
Okay, bubble sort.
Give me bubble sort.
Bubble sort is n cubed. I'm not going to go into a lot of details because we really are kind of short on time.
N minus
You have 3 loops, and you notice that it's in terms of n each time, and that's the important part. It's not some constant, right? It's not going to be plus. It's not going to start here at minus n, and then it's going to go to n plus 1 or something like that. We could go through and count this, but I really don't have the time. But the point is that because this starts, all these start on 0, and these are all in terms of n, you could say that this is going to be a big O of n, this is going to be a big O of n, and this is going to be a big O of n. So big O of n 3 times nested is going to be n cubed. Okay.
What about the n minus c part? One's definitely because it's going.
It's still going to be, if you're
down.
talking about, yeah, you're right. It is going to be a little bit less than that. But again, n over 2 is still a big O of n, okay?
Well, what
It's
about
still
that?
in terms of n.
What about that bottom 4 loop?
The bottom part here? This is just another for loop.
That's of n though. But it's outside of that, right?
It's outside of that, so it's
Or
just.
not array, but kind of.
Okay, this right here, so try and do these real quick before you leave. This is an n squared, this is an n cubed, so there's just a couple of typos.
Well, what? Oh,
So let's just go through these together. So Chris, for this one right here for A, what's going to be the dominant term here?
log in or n log in.
N log n, right? Because we can divide n out of both of these, which is going to go faster, 10 or log n? Log n, okay. What about for B, Lisa?
Oh, that's gonna be big O of n.
That's, well, this is n squared though, right?
Square.
This is n squared.
You can't divide out the ends.
Well, then what are you going to get? You're going to have n and you're going to have 2, okay? So what's
Yeah.
bigger, 500n or 2?
N.
Yeah, so this term's going to be the bigger one. So it's going to be n squared, okay?
Oh, okay, so then you go back and get the n squared.
Yeah, yeah,
Okay,
yeah,
I
yeah,
see.
yeah.
Okay, I see what you're saying. I didn't realize.
Yeah,
that.
yeah, if you're comparing them, you just let you, okay. Jesse, what about this one right here, C?
n cubed.
N cubed, right? That's much bigger than log n and definitely bigger than n. Kaylee's not here. Let's see.
That's wrong.
Joe. Is Joe here? Joey? No, not Joey. No, Joe. There you go. What about this right here, Joe? Well, n, right? Again, you have to get rid of the constant. You're right. It's this term because what? Log n is going to grow less fast than n, right? Slower. What about the next one? E. Ryan. Factorial, definitely. That's the big one, right? Hector, what about this one right here?
That's n square root n.
What's it going to be?
N root n.
Which is going to, okay, so we're going to compare these two terms. Get rid of the n's. Which grows faster, square root of n or log n?
I think it's n.
It's the square root, okay? So it's going to be n square root of n. Right? Because this is square root, this is log. We get rid of the n's, and that's what we're going to compare. Okay, so what about this last one? You see who? Gene. Yeah, square root's going to grow more quickly than the log, okay? Any questions about this?
Yeah.
So what's the answer, A?
That's plenty.
What about you? And log n.
Okay, so why isn't D also log n?